How much more will investment of $25,000 earning 4% compounded continuously for 4 years earn compared to the same investment at 4% compounded quarterly for 4 years? So we want to compare these investments, but not only compare them, but we want to see how much more an investment compounded continuously will make. So that means that we're going to do the difference of our two answers once we get them. So in order to answer these questions, we need a couple formulas. And the formulas that we're going to use are for periodic compound interest and continuous compound interest. So periodic compound interest is when you have regular intervals where you will add interest into your account. So this is what's described in the second account, where we're compounding 4% quarterly. So every quarter, interest will get added into the account, and that is a periodic interest. The other type is a continuous compound interest. And instead of waiting for these different periods of time, interest is continuously calculated and added into the account. And so we will use the formula when interest is compounded continuously. And you'll notice the first account is described as being compounded continuously. So what I'm going to do is I'm going to calculate what the investment would be if we took that $25,000 and had an interest rate of 4% continuously. And I'll also do the calculation of $25,000 invested at 4% compounded quarterly. And then we're going to be able to compare them. So going through the problem, the first thing we notice, we have $25,000 as our investment. That's going to be our principal, our initial investment, $25,000. And you can notice that in this formula for periodic compound interest as well as continuous compound interest, they both have P for principal, which is the initial investment. And then both accounts are paying 4%, and that is going to be our interest rate. And we're going to use that in its decimal form. So when you convert a percent to a decimal, a percent means per 100. So we're going to move that decimal place 2 places to the left, which is 2 powers of 10, that's 100. So percent per 100, we're moving that decimal place 2 places. So that's going to become 0.04. So in our formula, you can see that R represents the annual interest rate in both periodic and continuous formulas. And we're going to use that value of 0.04 in both formulas. And then we notice that we're going to be leaving the account alone for 4 years. So we have T being 4 years. So T is time in both formulas. And in the periodic formula, there's one more piece of information, the number of compoundings in 1 year. And we're going to get that value from the fact that this account is compounded quarterly. So if it's compounded quarterly, that means that interest is added quarterly or 4 times a year. So we're going to use 4 as the value of n. So now we're ready to use both formulas in the calculation. So we're going to find let's do the periodic account first. We'll say the quarterly one. And we have $25,000 as our principal times 1 plus 0.04 over 4 to the 4 times 4. There's a lot of 4s in that one. We're going to need to use our calculator to work that out. And then we're also going to figure out the investment if it were compounded continuously. And that's using this formula here, A equals P e to the RT. So we'll use $25,000 for P. E is a letter, but it's not a variable. E is the approximately the value 2.718. And it is used in this formula. It's used in lots of formulas related to exponential functions. The 25,000 e to the 0.04 times 4. That's the rate times the time. So I'll pull up my calculator. And let's see if I can make it a little bit smaller so I don't cover up those formulas. We've got 25,000 times 1 plus 0.04 over 4 raised to the 4 times 4. And that investment would pay $29,314, and we'll round to the nearest cent, so that's 47 cents. So 29,314 and 47 cents. And let's bring our calculator back up and do the other calculation. So that's 25,000 and we want E to the 0.04 times 4. That's $29,337. And once again, we'll round to the nearest cent, so that's 77 cents. 29,337 and 77 cents. So you can see that the investment that is compounded continuously earned more money. And this question wants to know is how much more. So we want to calculate the difference between these two investments. So we're going to do 29,333 and 77 cents minus 29,314 and 47 cents. And let's bring our calculator back up. This calculator has a nice feature where you can use the previous answer. So I'm going to hit second and this negative button. That's going to take the previous answer. Maybe I shouldn't do that because of our rounding. Let's not do that because of the rounding. So we're going to do 29,337.77, and I can see that I wrote down on my whiteboard the wrong value. So there should be a 7 here and a 7 here. And we're going to subtract 29,314 and 47 cents. And that gives us a difference of $23.30. So if we compound continuously, if we continuously add interest rather than periodically add interest, our account will grow faster. Thank you for checking out my videos. Have a great day.